Hi, everybody. What we're going to be working our way through today is introducing the idea of a periodic function. And so, just to get started, what you see in front of you are 5 graphs and then 5 situations. And so, what I want you to do is let's just take a minute to go through and try to line up what each individual application or situation would look like if we were to model it in a graph. So, pause the video right now. Take a quick 30 seconds, 1 minute to go through and try to match up each of those scenarios. Okay, we should be back. So if I was to start off with the first one, which is the height of a shot put, then when we go to throw a shot put, as time goes on, my height should decrease, but it means that at the beginning there was probably an increase. We should be looking at that as representing A. If we were to look at a record of a boy's heartbeat, I'm going to say if we struggled to get this one, I think we may struggle today. That one should be our B. And C, the cost of a taxi ride. Well, cost of a taxi ride could kind of, vary a little bit in terms of your expectation. But most taxi rides start with a fixed amount, and then it either increases based on the amount of time spent in the cab or increases at a cost per kilometer, that sort of thing. We should be looking at that being C. The distance a pendulum travels from its rest position. Well, a pendulum is going to swing, for instance, starting at its rest position and then go out to one extreme, come back, cross its rest position, and go to the other extreme, and so on. So we should be looking at this as being D. And, process of elimination should make the last one E. The growth of a number of bacteria. Bacteria exponentially grows. 1 becomes 2, 2 becomes 4, 4 becomes 8, and so on and so on. And so there's our E. So hopefully in just a quick minute or so, we were able to go through and match up all those graphs. What we want to focus in on today is not graphs like B, E, C, or A, but we're going to put our focus on D. So let's talk about what does it mean to be a periodic function. So if you take a look at the definition of a periodic function, there's 2 key components to it. A function is considered to be periodic if it has a pattern of y values. So what we're focusing in on are the y values that repeat at regular intervals. Those 2 key terms are underlined, and we're going to see where maybe there can be a little confusion with that definition. So a function is periodic if it has a pattern of y values that repeat at regular intervals. So we must see repeating y values, and they must repeat at regular intervals. So if we were to take a look at these 2 graphs provided, I've asked the question, is each of the following graphs periodic or not periodic? So your answer would simply be yes or no to this. Periodic or not periodic? So let's answer the question, is it periodic? So if we take a look at graph A, I hope that we see that graph A would not meet the requirement of being periodic. So the answer to periodic would be no. Now, that doesn't mean that we don't see a pattern. We can see a pattern in that. It increases, it decreases, it increases and decreases. However, if we were to make a note, my y value at this peak is about 4 centimeters. But I never get back to that y value of 4 centimeters. And so by definition, my y values do not repeat, let alone at regular intervals. And so therefore that one's a no. We take a look at the next graph, and we notice that we meet the first requirement. I have a y value of 2, I have a y value of 2, I have a y value of 2. The same thing on my -2, -2, -2. So my y values look like they repeat. The second portion of that definition is, do they occur, that repeating, at regular intervals? And so maybe I look at the distance between all of my peaks. Well, this to my next peak takes this long. And now I start to compare. Does it look like it's the same distance and the same distance? That looks like it repeats quite often. Well, maybe I don't look at my peak though, because that's really hard to tell. Perhaps instead, I look at where my function started and where it ends. So if I were to take a look at my starting y value, that would be a y value of 0. And I notice that my pattern goes up, down, and back to the beginning. If I was now to take a look, how long did that take? It took 0.2 seconds. Well, how long does it take to repeat the next pattern? Another 0.2 seconds. Another 0.2 seconds. And so because my y values repeat and at regular intervals, it takes the same amount of time to do that repeating, then if I was to answer the question, is that periodic? Yes. Okay, hopefully that gives us an idea of what we're talking about in terms of periodic functions. What we want to look at are some key properties of those. So I'm going to give you a minute just to read through all of these properties on the screen. These are properties that we would expect you to be able to identify within a periodic function. That's what we're going to do for the rest of today. So you would need to know what these are. So we would have no problem asking you, demonstrate a cycle of the function. What is the period? What is the amplitude? What is the equation of the axis? So I want to make sure that we have these. So if that means you're copying out these definitions, you do what you need to do to make sure that you are good at finding these properties. So a couple key things as we're working our way through. Cycle is what we talk about when we say one complete pattern of the function. So could you see a pattern that then is almost stamped out and repeated to form the graph of the function? If you can find that pattern, that is the cycle. The period makes reference to the cycle. And what it makes reference to is the horizontal length. So quite often, if you ask yourself the question, how long does it take to repeat? Your answer to that question would be the period of the function. The amplitude is defined as half the distance between the maximum and minimum values. And so if we're going from the max down to the min, or vice versa, then really what we're talking about is half the height of the curve. So half the distance from the max to the min is really half the height. The last part. You'll often hear this just simply referred to as the equation of the axis, but it can also be referred to more formally as the equation of the sinusoidal axis. All that equation of the axis references is what is the equation of the horizontal line that cuts the function in half. So it's going to run across your graph, right across the middle, so that the top portion of your graph is exactly the same as the bottom in terms of height. Okay, you make do with what you need with these, and what we're going to do is we're going to spend the rest of this lesson going through and identifying some key features of our graphs. So what I'd like to do now is just take a look at the question at the top of your screen. We need to state the period, amplitude, maximum value, minimum value, domain, range, and the equation of the axis for each function. So what you'll notice is below or beside each graph, I've just quickly jotted down what we're going to find for each one of these. What I'd like to do is I'd like to walk through question 2A. And then I'd like to kind of let you go for the remainder of B and C, and we'll see if we're good at identifying these features. Being able to identify features of a periodic function is the first part that's going to help you to solve problems when we get into dealing with it. So let's take a look at A. Okay, first thing I need to find is the period. And so you'll see that highlighted as a PD. For me to find the period of the function, the period is how long does it take to repeat. So if I need to find a cycle of that function, I notice that my graph starts at the top, comes down, then increases through this slight little wave to the top. And that green that I just highlighted, if I stamped it across the rest of the graph, down, up with a small little wave, down, up for the spot of the wave, and so on, would be my cycle. So for me then, I need to know, well, what is the length of that cycle? And it would run from the very beginning to that peak. And I look down and I notice that that took 2 x units. So my period is 2. Okay, what is my amplitude? Well, my amplitude is half the height. So I need to figure out what is the height of the graph. And I notice that my height happens to go, and that's kind of a rough line, right in between 2 and 4. So my height goes a max of 3 and all the way down to a minimum of -8. So that means that the total height of my graph would be 11 units tall. My amplitude would then either be 11 halves, or if you like, because it's exact, you could write that as a decimal. Well, to find the max and the min, I already had to do that to deal with the amplitude. And so my max is a value of 3, my minimum is a value of -8. Now I take a look at the domain, and I know that my domain are my possible x values. So the only thing that I need to really focus in on my graph is, does my graph continue forever in both directions, or is it limited in some sense? Well, when I take a look at this graph, what I notice is that this graph starts here but has an arrow on the end here. That's telling me then that my graph is equal to 0, but then increases forever. So you can either give 0 to infinity, or feel free, you can still write that x must be greater than or equal to 0. Okay, what is my range? Well, I notice I already kind of found my range when I had to deal with my max and my min. So my range has a bottom of -8 up to a top of 3, or y is in between and equal to -8 to 3. Okay, the equation of the axis. The equation of the axis now is asking me to find what is the horizontal line that runs directly down the middle of that graph. For me to find that, I use my amplitude. I know that my amplitude is half my height. So if I travel half the height down from the top, or half the height up from the bottom, then I know I'm going to arrive in the middle. So if I go down 5.5 from the top, or up 5.5 from the middle, then I will have my horizontal line directly down the middle of that graph. What is the equation of that line? It's a horizontal line, so it's a y equals, my y value is equal to -2.5. Or, of course, you could keep that in fraction form and say -5 halves. Okay, there are all the key features of a periodic function that we need to be able to identify. What I'd like everyone to do is to go ahead and pause it and then work their way through B, and we'll see if we match up with all of the answers to B. Okay, we should be back. So pretty quickly here, I noticed that I need to identify my period. Well, my period means I need to know a cycle. And one of the mistakes we could have made was we kind of highlight this section. Because we start at the top, we fall, we go across, we get back to the top. I just want you to notice that is not the cycle highlighted in green. Because if I was to repeat it, then I would have to begin coming down. And notice I'm not tracing my curve anymore. So, for me to have my cycle, it also has to include that little horizontal portion there. If I was then to go and repeat that pattern, down, across, up, across, Notice I'm tracing my curve. So how long does it take to complete that? Well, from 0 all the way to the end, that was 4 units. What's my amplitude? Well, my amplitude runs from 4 down to 2 as my height. So my height is 2 units, amplitude is half of that, so I have an amplitude of 1. What is the max? The max was 4, while my minimum was 2. My domain, I notice that neither my beginning nor my end have arrows on it, which means that my graph begins and stops at those points. So that means I have a domain from 0 up to 10 inclusive. What is my range? My range is going from my max and my min, and so therefore my minimum value is 2 up to a maximum value of 4. The equation of the axis then would tell me go 1 unit, my amplitude up, or 1 unit, my amplitude down, and I can pretty easily see that y equals 3 is the middle of my curve. Okay, hopefully we matched up, and now we're just using this last problem for us as total confirmation that we're good on identifying these properties. So I'd like everybody to stop the video and work their way through C. Okay, we're back. And so if we were to identify our way through C, my graph starts at the bottom, and for me to repeat my cycle means I have to get back to the bottom. That pattern would then repeat. And so if I was to look, I would be directly down in the middle of 135 and 225. Now I notice on my scale that each one of those tick marks is 45 degrees, so that would put me at a period of 180 degrees. What's my amplitude? Well, that's me going from this value, which is 6, up to this value, which is 12. That would make a height of 6, which means my amplitude is half of that, 3. What is my max? 12. What is my minimum? 6. What's my domain? Well, I take a look and I notice that I have arrows on both ends this time. And so therefore, my x values could be anything. My range, however, is going to run from a bottom of 6 up to a top of 12. My equation of my axis. Well, if I was to mark the horizontal line that would go directly down the middle and cut that curve in half, then I would drop 3 from the top or go up 3 from the bottom, which would get me to a y equals 9. So there we go. Hopefully everything matched up, and we're good at dealing with the properties of periodic functions. Your job now, jump in and play around with some practice. Good luck.